Good morning, my name is Karen Salazar.
My name is Crystal.
And Agueda Durazo.
And we're doing chapter 14, algebraic thinking. And algebraic thinking is far from the topic with a little real world experience. It has everything included. It helps the students to think mathematically in a real world situation and basically. Five different forms of algebraic reasoning is generalizing from mathematics and from patterns in all mathematics. Meaningful use of symbols. There's a lot of misunderstanding of the symbols. Like for example, Cashman in Spain, the equal sign. There's a lot of students that confuse it with the and the answer is instead of the equals meaning. Studying structure in the number system and studying the patterns and functions. And the last one is processing mathematics, modeling and integrating the first four lists. Okay, generalization from arithmetic and from patterns. For example, in the chapter, it gives that example of the monkeys and the trees, and it's helped the students as for like first graders, beginners. Everything like this start from kindergarten until high school, and each year is progress. That one, it helps the student, for example, divide. It gets seven monkeys, and they get two trees. One is small one, and one is big. So you ask the students to divide them. So you can do separate groups, and then it helps the students to decompose the seven, but also think of ways to make it as well as seven again. For seventh graders, they use a better, a little bit more hard for them with the formula using like three different numbers and even using the letters included. And then for the generalization through exploration patterns, that example also gives in the book, and it's helping the students not count one by one the little squares, but for example use the formulas. Think about it, like use the simple ways to find out how much is it the one outside. And the meaningful use of symbols, like I say, the meaning of the equal sign. A lot of students misunderstand this, the equal sign. They just think that and the answer is not thinking about kind of like a little basket, having the balance in there. And true and false in open sentences. That one I can help the students to know if they're right. Well, not right, but to know if the sentence is true or false. You will give like example like those, and then you will ask the student if it's correct, if it's true, or is it false. The student will kind of figure it out, the answers, and they will see, like for example, 4 plus 5, that's 9, and 8 plus 1 is 9. So it is true, that one. And then for open sentences, you write the equation, but you just like miss out one number, so they can figure out which one it is to keep the balance. And then for relationship thinking, takes place when a student observes and uses numerical relationship between two sides of the equal signs rather than actually computing the amounts. The meaning of variables. Variables use the unknown value. For example, the equation that we always know, like for example, n plus 7. That's you don't know exactly the amount that it means the n. It can be any numbers, it can be infinity, it can be everything. And simplify expression and equation. Student needs to know the actual way to simplify it, but keeping the order. And variables use a quantity that varies. The best for that one that I can explain is the one that we always knew, that x plus y and 2x plus 1, that you had to figure out what's the answer for those.
Okay. We have the making structure and the number system explicit. This is a properties that are teach informally. So with these properties, the student kind of picks up that on its own automatically, but they have to understand if it's true or false. For example, I'll give you an example. 394 plus 176 equals n plus 394. There the student automatically knows that n equals 176 because it's the same equation. You understand that? So that's taught informally. And then we have making conjectures about properties. It's around the same thing. 41 plus times 3 equals 3 times 41. Here, students know also this automatically just by looking at it, but just by looking at the equation. Students also have to focus and investigate in the disrupted and associative properties and only know if it's true or false. So here the student also needs to know that, for instance, if we change it to 2 times 8 plus 2 times 8 equals 16 plus 16, the student there needs to know that there's other ways of getting the answer. For instance, if you see it over here on the side, it says 2 times 8 plus 2 times 8 is the same as 32 because 16 and 16 is 32. So they need to be aware of that there's other methods of getting the answer. It's not always going to be 394 plus 176 equals 176 plus 394. They have to find disrupted and associative also conjectures. I didn't know what conjectures was. I don't remember if I'm pronouncing it right, and I looked at it and it's assumptions, right? Yes? Okay, so that's something that I wasn't aware yesterday when I was like reading the chapter. I wasn't aware, so I had to Google it. We have the odd and even relationship, and this one, I mean, everybody knows the odd and even relationship. The students learn that, I mean, at early grades in the elementary. And the students here, they know automatically that the sum of two even numbers is going to be even, or the sum of two odd numbers is going to be even, as well as the sum of an even and an odd number, it's always going to be odd. That's something that the student also automatically knows. For instance, the book gives them an example. If you have two odd numbers and you split it in half, your answer is always your pair is gonna have one left over. So that's why it's an odd number, because they don't have their pairs. Students can find different answers as to why it's true. It's like I was telling you before, they have to understand why that is true. They have to find ways of how to find the answer. Why does that equation equals the same equation? They have to find different methods of how to get it. We have to study patterns and functions. This is repeating patterns, which we all know. Like, for instance, if I clap and then I stomp and then I clap and I stomp, you already know what's going to be next, right? So what's going to be next? Right? Yes, it's a clap and a stomp. So that's a repeating pattern. And they use the book. If